Here's our last two questions. Question 9 deals with a profit function, negative 0.2x squared plus 22x minus 400. And we are asked in part A to use the marginal profit function to estimate the profit from the sale of the 41st calendar. Now compare this to driving down the road and knowing that you're currently traveling at a speed of 60 miles per hour, which is 1 mile per minute. This question is asking about the 41st calendar, not the profit we've made from the first 40, but how much profit are we going to make with that very next calendar? Just like as we're driving down the road, if we're traveling a mile per minute, and we think about how far we're going to go in that next minute, we're not going to add all the miles that we've driven so far. We're only thinking about that next minute. So it should be a mile in that next minute. Well, because this says marginal and we're talking about a rate of change, we want to find the derivative of this profit function. And so we just use the power rule. We bring the 2 around front here and multiply that times negative 0.2, which gives us negative 0.4. And of course subtract 1 from the 2, and that gives us negative 0.4 to the x to the first. And then the linear term 22x just as a derivative is the coefficient 22. And of course the constant differentiates away because it does not affect the rate of change. Now, for that 41st calendar, we substitute 41 in for x. And so this is negative 0.4 times 41, and this should really say p prime of 41 here, but I neglected to do that. But we substitute 41 here into the derivative function. Negative 0.4 times 41 is negative 16.4, and then we add that to the 22 here, and we get a estimated profit for the sale of that 41st calendar of $5.60. Now, the second part asks us, well, what is the exact profit from selling the 41st calendar, assuming that this function accurately reflects the profit that we're making at any particular level of sales. Well, to do that, we use the profit function to find out how much we would make in profit from selling 41 calendars, and subtract from that the profit we made in selling those first 40 calendars. And so I substitute 41 into the profit function now, not the derivative. I substitute it into the profit function, so I have 41 here, x squared is 41 squared, and I have 41 here, 22 times x, 22 times 41, minus 400. And when I simplify that, I get 165.8 dollars. And then what profit was generated by selling the first 40 comes from substituting 40 in for x. So this is negative 0.2 times 40 squared plus 22 times 40 minus 400, and that simplifies as 160. Subtract 160 from 165.8, and so the exact profit is $5.80. Now, question 10 says that a textile manufacturer has daily production costs that are given by this function here, where x is the number of units of fabric produced. And we're asked in part A to determine the average cost per unit if 900 units are produced. Well, excuse me, The average cost function, average cost per unit, is indicated by this C with the bar. And if we put the cost function in the numerator and x, the number of units, in the denominator. If we make if we have if we have 10 units that cost us $1,000, then we'd have 1,000 here and divide by 10, and that would be $100 per unit. But we don't have a specific amount just yet. We want to create the general average cost function, and so we put the function in the numerator, x in the denominator, and we simplify that by separating each term here into separate fractions. And so we have 0.04x squared over x. One of the x's cancels, and that leaves 1x here. And then we have negative 110x over x, and of course the x's cancel, and that just leaves us 110 here, minus 110. And then the 100,000 over x can't be simplified in any way, so we just write it this way as 100,000 over x. Now, what is the average cost per unit if we're making 900 units? Well, to find that out, we substitute 900 into the average cost function, and so that's 900 for x here, and so that's 0.04 times 900 minus 110, and in this last term, 100,000 over 900, 900 for x here. And when we simplify this, we have 36 minus 110 here, and 100,000 divided by 900 is 111.11, and that 1111, and that doesn't, it repeats and never terminates. So that's approximately $37.11 per unit. Now, part B says, well, what is the marginal average cost at a production level of 900 units? Marginal average cost is what the average cost at 900 units is doing. Is it increasing? Is it decreasing? What is the rate? What is the rate of the average cost at a level of 900 units? Well, marginal means derivative, and so we differentiate this, the average cost function, and so that means that the linear term loses its variable and the coefficient stays behind. And then I have written 100,000 over x as 100,000 times x to the negative 1, because that's the x in the denominator. We give it a negative exponent and bring it up to the numerator, and then of course the 110 differentiates away because it doesn't contribute to the rate of change. And when I differentiate this term, 100,000 over x, I've written it as 100,000 x to the negative 1. Remember, I bring that negative 1 out front and I subtract 1 from that negative 1. And so now this becomes minus 100,000 x to the negative 2. Well, x to the negative 2 can be written with a positive exponent by bringing the x down, back down to the denominator, and changing the exponent from negative to positive. So this is the marginal average cost function, and we want to know what the marginal average cost is at a production level of 900 units. So we substitute 900 in for x into the marginal average cost function. So that's a 900 down here squared. We have 0.04 minus 100,000 divided by 900 squared, and that comes out to approximately negative 0.0835. And there's more digits, but I rounded it here to 3 significant digits. And so at a production level of 900 units, what this means is, what this rate and this negative means is that at a production level of 900 units, the cost per unit the cost per unit is decreasing at the rate of $0.0835, or that would be 8.35 cents. So the cost per unit is decreasing because we have a negative. Now notice that I wrote this as a positive because the negative is built into the word decreasing. And then finally it says use the results of parts A and part B to estimate the average cost per unit if 901 units are produced. Well, the average cost per unit when we make 900 is $37.11. But we know that that cost is going down at about 8 cents or 8.35 cents per unit. And so we add that decrease in cost to the cost for the 900, and this is the estimation of what the average cost per unit is going to be if we increase our production by 1 unit.